Okay, guys. Good morning, everyone. Welcome, everyone. Very warm greetings from Mercy Technologies. So, yesterday I have given you an introduction to three other data structures, which is arrays, stacks, and queues. So, yesterday we have learned about all the theory about those things, and we actually have written some pseudo code so that the code should be something like this kind of. So we have ended with that note yesterday. So now let's see. Today is a continuation for that, and let's see what is our agenda for today. So this is our agenda. This is a simple agenda for today. So we'll be implementing stack. We'll be implementing queue, and stack will be implementing using two ways, which is one is using an array, and the second is using a linked list. Queue is also the same. We'll be using an array to implement a queue, and we'll be using a linked list to implement a queue. Just I'd like to brief 2 3 points about stack and queue, and we can move forward. So I told you stack as an example yesterday. I told you stack would be something like a stack of plates either on a restaurant or in a home, right? So what you do when you want to take some plate, you'll be taking it from top, you'll not be taking it from bottom, right? When you want to place a new plate over that, again you'll be doing that on top only, right? So which means either addition or deletion, insertion or deletion happens only at one particular point, which is we name as top, right? So for every data structure, there are ways to insert and delete. That is the way of modifying it, right? So every data structure has a different naming convention. Stack, the insertion is called as push, and deletion is called as pop. Similarly, in queue, if we take a real-time example of we are standing in a queue to purchase ticket, right? A movie ticket or whatever it is, right? So how it is done, let's say we join the queue, we go in, we purchase a ticket and we come out. So which means the deletion happens at an end called front. And how is the addition happening? Let's say there is a very big queue and you go and join. You will not be joining at the front, you'll be joining at the rear, right, at the back. So insertion happens at rear and deletion happens at front, right? There are 2 points here. And queue, one more important point that I want to mention over here is, as I told you, for every data structure there will be naming conventions to the operations, right? In a stack it is push and pop. In a queue it is called as enqueue, and deletion is called as dequeue, right? Enqueue and dequeue. As I told you yesterday, we should be implementing these methods in order of one time complexity, right? We can implement straight away, but the interviewer says you have to implement that in order of one time complexity. So to do that, we have written a small chart yesterday, right? I'll be showing that to you again, but we have written a small chart yesterday. We'll be taking that as a reference, and we'll be formulating a few things, and from that onwards we can start implementing, right? We can start implementing. So one more important point that I missed yesterday is, this is not important, this is very intuitive, you can understand that stack, the insertion, or it follows LIFO, which means last in first out order, LIFO order, right? The last in first out, the one that came in the last will be going out first. And queue will be following a FIFO order, first in first out. The one who came first will be going first, will be going out first, right? Stack uses LIFO and queue uses FIFO, right? This is some important revision, I can say. It's not it's a high level revision, I can say. Let's move forward and see, right? So I told you yesterday, somebody was asking me that in this case what happens, in that case what happens. Yesterday I've just written you a simple sample code, just want to give you a feeling that these codes are not too big. These are small codes. Only thing that's required is we need to put you know more amount of concentration on writing it. So not just writing the code, guys. Writing the code is so simple, but doing that background work for that, understanding what exactly is to be written on the piece of paper or in IDE is very important, right? So that's why today what I'll be taking is I told you that before we start writing any code, we need to explore our base cases, right? Base cases is very important. Let's try to explore the base cases today. And after that, we will be writing the code for implementation. As I told you, as per our agenda is to write 4 programs, and we'll be writing all the 4 programs, right? So let me start, giving you few things over here. I've written a Excel sheet. I can say I've formulated a few things, but before that, let's move forward like this and say, I think whiteboard is stuck. Just a second. Okay. So here, as I told you, in linked list, if you remember, let's say we have written a program which is insert, right? Insert. So we have taken base cases, right? What if, head is equal to null, right? This is one case that we have written. So what, this is a base condition, right? This is a base condition. So similarly, if we are representing linked list using sorry, a stack or a queue using linked list, we'll be having similar kind of base conditions, right? We'll be having similar kind of base conditions. But before that, let's concentrate on array, right? Using an array, what would be our base conditions is what would be our base conditions is. So let's say I told you we have a variable called top, right? This top is very important, right? This is very important. And insertion or deletion happens on top. Insertion or deletion happen only on a particular place called top, right? On a particular place called top. So here in this point, what I want to say is, for example, let's say you have two operations, right? One is push and pop, right? So what should you be pushing? Let's say it is x, like, right? You should be pushing a variable called x, right? So in this particular point, it means it is an insertion. Let's say our stack is not containing any element, right? Our stack is not containing any element. So what should you do in that case? For example, let's say what I call that as is uh, okay, instead, so there is a condition called overflow. Okay, right? For example, let's say you have taken the max size of the list to be 100, right? You have taken the max size of the stack to be 100, but let's say you're trying to push one more element which is 101. So in that case, it is crossing that condition. So that condition is called as an overflow condition. So let's say there is no element at all which is present inside the stack, but you're trying to pop it, means you're trying to delete it. That condition is called as underflow. Okay. So which means there are two base conditions which we got, which is overflow, which is underflow, right? Overflow and underflow. So let's say we need to implement this methods push and pop, what, in order of one time complexity. So we'll be taking care of overflow and we'll be taking care of underflow, right? So this overflow, let's say I write a method called isFull, right? I write a method called isFull. And for underflow, let's say I write a method called isEmpty, right? There are two new methods. One is push, one is pop. I have two methods already. So I need to take care of overflow and underflow conditions, which is I need to take care of isFull and isEmpty conditions, right? Total altogether, we got how many methods? We got 4 methods. Let's say for our safety purpose, or out of this, just the intention to implement, let's say I want to maintain the count, right? So here, let's say I want to maintain the count of number of elements inside the data structure, let it be queue or stack. So what will I do? I'll write, let's say I write one more method, which is count, right? I write one more method, which is count. So what I just want to explain over here is, when we try to implement something, we need to take care of base conditions as well. To implement the base conditions, if we write a separate method for that, then that will even be looking even better for the interviewer. So at this point, guys, so we have concluded that we'll be implementing 5 methods: push, pop, isFull, isEmpty, and count. Right. So without wasting any more time, I want to show you just the chart that I have written. Right. Yesterday, if we see what I told you, the time and space complexity, the time complexity that we need to use for implementing those is order of 1. So that is why should we be inserting at end, should we be inserting at beginning, etc., etc. We have taken examples and found out that what happens when you insert at a particular end. So today we'll be continuing with this explanation. So what I'm doing is, sorry. So what I'm doing is, for example, let's say I'll concentrate only on, okay, fine. So we'll straight away do this. So let's say you are implementing using an array, right? Using an array, and what you're trying to do, you're trying to implement a stack using an array, So what I told, there will be some initial conditions, right? There will be some initial conditions as per our initial condition, So this is what, let me just move this up, right? Let's say a stack is there for you, which is looking like this, right? I told you there is a variable called top, right? Top. So what should you initialize this top to? Top should be initialized to -1, right? Top should be initialized to -1. You can initialize that to 0 and all, guys, but that's fine. I mean, it was causing a bit problem for me while implementing, so that's why I'm taking this initial condition to be -1, okay? And empty condition, right? I told you we need to implement a method called isEmpty, right? isEmpty. So there is this method called isEmpty, right? How do you conclude that your stack is empty? Your stack is empty. Let's say there are few values like this, and let's say our top would be somewhat like this, right? When top is somewhere over here at an index of 0, 1, 2, 3, at an index of 3, which means stack is having some value. But let's say the top is present at this particular point, at a point where the initial condition is still there. When the initial condition is still there, so indirectly I'm saying it is an empty stack, right? It is an empty stack. The same thing that I'm writing over here, top is equal to -1. When top is a variable and it is pointing to -1, which means I'm saying it is an empty stack, right? I told you we'll be writing one more method, which is isFull, right? IsFull. So how do we conclude that? IsFull is top is equal to length -1. For example, let's say in our case, what is this? The length of the stack is 1, 2, 3, 4, right? 4, right? What is the index? Index starts from 0, 1, 2, 3. So when top, which means 4, which means let's say top is equal to length -1, which is 4 minus 1, which is 3, which means the index of top is equal to 3. The index of top is equal to 3. So which means here I conclude that it is a full. So here what am I initially saying? The maximum length of the stack would only be 4, right? It has already reached to that particular point and saying there is no more space left. So that is why we can conclude that the stack is full, right? So what is a full condition saying? Full condition is saying when top is equal to length -1, so which means you are concluding that it is a full stack. Now we need to maintain the elements count also. I told you we'll be writing one more method, which is count. So how do you say how many, what is the count of elements here? Count of elements here is 0, 1, 2, 3, 4, right? Count of elements is 4. So here what we say, top plus 1. What is that top pointing to? Top is pointing to value called 3. Top is pointing to a value called 3. And when 3 plus 1, which is 4, 3 plus 1, which is 4, which means our count will come top plus 1. Every time, what is the count? Count is equal to top plus 1. So these are the initial conditions, guys. These are the initial conditions, or these are the things that we need to have a clarity before we actually start coding, right? These are the conditions that I have written. Okay. So we'll use all these conditions in our code just to see if we are able to achieve what we wanted or not. Let me repeat this once more. Initial condition will be having top is equal to -1, empty top equal to -1, full top equal to length minus 1, elements count top plus 1. How did I achieve all this? Just by taking some examples. I've taken some example over here, and just by looking at this, I'm able to achieve, or I'm able to write all this, right? So let's say we try to use all these conditions and we implement it, right? I'm straight away going into the code so that you feel even better, right? What is that? My stack using an array. Okay, so I'm showing you the code straight away, guys. I'm showing you the code straight away. I just want to, implement that. Yesterday, I have written a pseudo code. I have written an algorithm kind of a one. Now I'm straight away showing you the code. So what is the initial condition? Initial condition says top is equal to -1. This is our initial condition. And then, so I have taken an array, right? I've taken an array, which is an integer array. Here I'm saying, let's say the maximum size I'm saying is only 5, right? The maximum size I'm saying is only 5. That's what I said. So we need to have a size for that, right? So again, we have written methods called push and pop, right? What is push doing? Push is inserting, and then pop is deleting, right? So before we actually push or actually pop, I told you we need to take it into two conditions, which is empty and is full. What is empty saying? Is empty saying the same thing. Is empty saying top is equal to -1. If top equal to -1, then you say that it is an empty stack, or else you say it is not an empty stack. Same thing is full. So I told you what is the is full. Length is top equal to length -1. I'm saying the same thing. So top is equal to array dot length -1. Then you return that as true, right? Else you return that as false, right? So these two methods I've straight away implemented, is empty and is full, right? So there are two more methods, push and pop, right? Push and pop. So let's say what happens to our push method. Push method, first before we push, we need to check if it is a full stack or not. Like if it is full, then I told you there is something called stack overflow. Here I am just printing that as stack overflow, guys. But actually in the real time and all, like we will throw exceptions, or we handle that in a different way. We will throw error codes, etc. But just for an illustration purpose, I'm just printing stack overflow. So if it is not stack overflow, which means it is not full, what am I trying to do? I'm trying to insert. Yesterday I have explained you why am I doing this. Array of plus top is equal to x. So what am I trying to do? I'm trying to inserting that into an array. What is my array? Right? What is my array? Array is something over here. I told you. So inside this array, I'm doing this plus top. Same thing I'm doing pop, right? For pop, what am I trying to do? I'm trying to check if it is empty or not. If it is not empty, then I'm modifying, or I'm popping it out, right? I'm returning what? I'm returning an element that I'm trying to delete over here. What am I trying to do? I'm returning an element which I'm trying to delete over here. I'm returning, and then that's it. So in case if I'm trying to delete, which is an empty stack, then what am I trying to do? I'm saying it is a stack underflow condition. So it is a stack underflow condition. This is so simple code, guys. Like just by having some chart like this before we start writing the code, if we have some chart like this, by taking examples, then our coding will be so easy, because we just need to implement all this, right? We just need to implement all this. So with this, let me try to remove all this. Okay, let me try to remove all this. I did not write a method for count, guys. It's a homework for you, but I'll tell you before we end the session for today, right? So here, what am I trying to do? I'm trying to push these methods, right? Push of 10, 20, 30, 40, 50. So I'm trying to push this 5 and say I'm printing that stack. So inside a print stack, I'm just iterating and I'm trying to print something. So let's try to run this method for now. So what am I doing? I'm running this code, and here it goes 10, 20, 30, 40, 50, right? The insertion 10, 20, 30, 40, 50. So the top should be pointing out to this 50, right? Top should be pointing out to 50 because the insertion is having at 50. Let's try to debug and see what exactly is going on, right? I have put a debug point on 43. So here I'm saying debug as a Java application, right? Right here the value of top, you see this, the value of top is coming to be 4. 4 is not the actual value, guys, it is the index. The index of the array starts from 0. Yesterday we saw that, right? It starts from 0, which means it is at value of 4, which means it is pointing out to the fifth element, right? Fifth element, which is 50, right? It is pointing out to 50. Let's say I try to insert more, it takes different things, right? So here, what am I trying to do? I'm trying to say that the top has incremented to a value called 4, and the actual size of the array is now 5, right? So let's try to even do other things. What we try to do here, we have initialized that to 5, right? Now let's say I'm trying to insert a sixth element, right? I'm trying to insert a sixth element. I'm trying to insert a sixth element, which is 60, right? What happens in that case? There should be a stack overflow, right? There should be a stack overflow, right? There should be a stack overflow. Let me try to run this. Yes, guys, stack overflow. And then I'm printing as well, right? I'm printing. So these are exception conditions. You can take care of all those. What I just want to show over here is there is a stack overflow. The reason is it is crossing this condition. This is where it is getting printed. So line number 11 is getting executed, right? So let's say I'm removing this, right? I'm removing this. Let me come back to my original code. I have cut that, okay? Right? So here, what am I trying to do? I'm trying to test pop method. What am I trying to pop out? Let's say after I insert 5, I'll be popping out. Let's say I'm popping out 3 items, right? I'm popping out 3 items. Let me try to run this one for you. When I try to run this one, so it says 10, 20, 30, 40, 50, and I'm testing my pop. Here it says popped out element called 50, popped out element called 40, popped out element called 30, right? The insertion is happening over here. Insertion is coming at the right hand end, and then even the deletion is coming at the right hand end, right? The deletion is coming at the right hand end. So with this, what I want to conclude is, guys, with just by using this simple array, right? We have taken this array, we are able to implement our logical data structure, which is stack, right? Which is stack. So like we are not actually deleting and all, we are not actually deleting. Popping out means we are not actually deleting those values. If I try to print, it will be printing, but our intention is not that, guys. Just by modifying this top, just by modifying this variable called top, we are able to achieve the things of a simple stack. The push and pop operations, we are able to do that in order of 1 time complexity, and we are able to implement the methods that I initially discussed with you. What are the methods that I initially discussed? The methods that were initially discussed is push, pop, is full, is empty, count. You can maintain a count. That's what I told you. And you can give, like, let's say you can take that as a homework for you. You need to write a method called count or get count, and you need to maintain a variable called count, and you need to give me the length of that array. That's it, right? So with this point, guys, I just want to ask you. Okay, guys. So we have done stack using an array, right? Stack using an array. Now let's try to implement queue using an array, right? Let's try to implement queue using an array. I'm trying to take a small example over here. I'm trying to say take small example over here. So what is a small example that I'm going to take? 1 second. Okay. What is that small example that I'm going to take? This is a small example. Let's say there is a queue something like this, right? Let's say there is a queue something like this, 1, 2, and 3, right? So there are 2 pointers, front and rear. So I told you front is the place where deletion happens, and rear is the place where insertion happens, right? Insertion happens. So I told you how deletion happens. So the deletion name is called as dequeue, right? There is a method called dequeue, and insertion has a method called enqueue. So what you are enqueuing something called X, right? You are enqueuing something called X. So I told you So I told you that there is an element called front over here. Let's say front, and this is rear, right? This is rear. This is front, and this is rear. So these are the two pointers. These are the two pointers. These are the two pointers. The insertion happens at rear and deletion happens at front. Now let's try to conclude, or maybe let's try to write the conditions so that it becomes easier for us, right? So what are those conditions, guys? Those conditions: initial condition. Those conditions are initial condition is full, right? Is empty, and what is the other? Let's say get count, right? These are the four methods, let's say. So what is our initial condition? My initial condition is, I'm saying front is equal to rear is equal to -1. I'm incrementing, or I'm initializing that to a number called -1, right? -1. So is full condition. So when I say full, when would I say full, right? When would I say full? If we think, that formula would be so simple, right? Rear is equal to length -1, the simple, right? So rear is pointing out to an index. Let's say this is of index 0, this is 1, this is 2. It is pointing out to an index of 2, which means when rear is equal to length -1, so which means it is full, right? So which means rear is equal to length -1. Simple. Is empty, right? Is empty. So if I'm telling you initially I'm saying front equal to rear equal to -1, which means front is equal to rear is equal to. So which means these two are equal at this particular point. I can say front equal to rear, right? In this case, I'm saying it is an empty queue, right? In this case, I'm saying it is an empty queue. And how do I get the count? How do I get the count? The count is nothing but, if you see, the count is nothing but rear minus front, right? So here 2 minus 0, right? Rear minus front, plus you have to increment a point, right? Rear minus front. What is this? Rear is giving 2. Rear is 0 1 2, and minus front, which means 2 minus 1, which means 2 minus 0, which is 2. It's plus 1, I think. So we need to add something like this, guys. Just correct me 1 second. Rear minus front plus 1. So we need to add some condition, something like this. Rear minus front will be giving you the count, right? The same thing. So we have concluded our 4 points over here. We have concluded our 4 points over here. The same thing I'm trying to implement that in our code as well. So in our code as well. So what is that? My queue using an array, right? I have written some code, something like this. My queue using an array. I've taken an initial condition, the same initial condition, right? Same initial condition, and then enqueue and dequeue are the two methods that I've written, right? Enqueue and dequeue are the two methods that I've written. So before we go into those methods, what I did, is empty and is full. These are the two methods that I'm trying to write. Is empty. What is our empty condition? Empty condition, front equal to rear. If front equal to rear, return true, or else return false. Simple, right? So again, the full condition, what am I trying to do? Rear is equal to array dot length minus 1. If yes, true, or else you return false. So these are the two simple conditions I've written. That's fine. So enqueue, when I try to enqueue something, I'm checking, is it full or not? If it is full, then like here also, similar to that code, I can write that it is a like it is a stack overflow, it is an underflow, whatever. So I want to, in the else condition, I can write whatever, but this is just a duplicacy, guys. I just want to show you what exactly is required. So here I'm saying, if it is not full, then you try to insert array of plus plus rear is equal to x. This, I mean, explaining this is not, what you call that hard. The only thing is, like, I want you to take some examples and actually feel, oh, this is what we are trying to write in this code. This is what we are trying to write in this code, right? Array of plus plus here will give you an x, which means you are trying to insert at a point called rear, right? In the dequeue, I'm checking if it is empty or not, and if it is not empty, I told you we will be deleting at a point called front, right? We'll be deleting at a point called front. Same thing, guys. There are two pointers over here. and this is the insertion logic, this is the deletion logic, right? And we have written two more methods, empty and full, and we can write one more method, get count, and using that formula we can actually find out what we are trying to do. I'm not running this code, guys. This is I just want to show you, this is the way we will be implementing Q, right? This is the implementation of Q using what? Using an array, right? Using an array, I have implemented a Q, and I just shown that to you, right? Guys, you are able to understand the conditions and the simple code. So with this, guys, what we did till now, we have implemented stack and queue in order of one time complexity. You just need to find out, even are we doing that in order of one time complexity or not, guys? That is also homework for you. I've done that, but at the same time you need to analyze that, right? So what I try to do is, till now we are done with this part. Using an array, we are able to implement stack. We are able to implement a stack, and we are able to implement a queue as well. Right? Now let's try to use linked list, right? This is one more important easy question, guys. So you need to use a linked list to start implementing an array and start implementing a start implementing a queue and start implementing a stack, right? So in yesterday's explanation, what we did is uh, so in a linked list, when you try to delete at the beginning, right? Delete at beginning, the time complexity will be of order of 1, which means we need to take the top. As I told you, the insertion and deletion will be happening at only a single end, which is called as top inside, in terms of a stack, which means you have to either delete and insert at the beginning, right? At beginning, when you do this insertion or deletion, you can do that in order of one time complexity. So similarly, what I'm trying to do, I'll be implementing. Let me take small example and try to explain you what is that small example. Let me go back to our whiteboard, right? What is that whiteboard? For example, let's say we are trying to implement that using a linked list, right? Something like this. 2, 1, here it goes, and here you're saying null. This is our head, right? This is our head. This is this simple implementation. But here we are trying to do one thing, which is stack, right? So what I did, initial condition. So what have I taken the initial condition as? The initial condition as, I'm taking a value called top is equal to null. This is top is what? Of type node, right? You are initializing that to a value called null, right? You are initializing that to a value called null. Same thing, I've written the same thing over here. That is our initial condition, guys. That is our initial condition, right? So again, what you have to do when you are saying it is an empty, so I told you it has been initialized to null. It is an initialized to null. So when top is equal to null, so what you can conclude it's an empty stack, right? When top is equal to null, then it's an empty stack. So here one more thing is full condition is not available for linked list case. The reason is, in array, as I told you, in our short code, what we have written, we have written something like this. So I've initialized that to a value called 5. But in linked list, it's not like that. In linked list, you can start inserting the nodes until a point where your memory, your primary memory, or your actual memory in the system gets exhausted. So it's like it's not finite. Like it's a number of 5, it's a number of 10. It's not like that. So that's why there is no condition called is full, because you do not have an initial size of the linked list. You can start in inserting it until your memory gets exhausted. So that's why I'm saying the full condition is not available when you're trying to implement using linked list. And how do you maintain count? You can maintain if you want to get the elements. So we need to maintain some count. I think I remember in linked list we have written some program where we keep the count and we give the length of the linked list and all, right? So you can even refer that and maybe try to implement this method, elements count. So here the initial condition top is equal to null, empty condition top equal to equal to null, and full condition is not available. So with this understanding, and one more thing that I told you is we should be inserting or deleting, only at beginning, so that the time complexity will become only order of 1, right? With this understanding, guys, let me straight away jump into the code and show that to you, right? My stack using linked list. Okay, this is the method, this is the class, I can say. So what is the initial condition? Top equal to null. This is the initial condition, and we have written two methods, push and pop, right? We have written two methods, push and pop. So I told you for pushing, okay, fine, and we are only checking for is empty condition because there is no is full condition. So is empty condition, what is our is empty condition saying? Our is empty condition is saying if top equal to null, then it is an empty condition, then it is an empty one, right? I'm doing the same thing over here. Top equal to null, then you return true or else you return false, right? So here what am I trying to do? I'm trying to push, right? So if you observe this code, guys, if you observe this code, you should be inserting where? So here you say insert at beginning, right? Insert at beginning, right? So if you remember, we have written some method, or in the insertion of linked list, we have taken three cases: insert beginning, insert at index, and insert at end. So insert at beginning, you try to refer the code that we have written for insert at beginning, guys. This is the same code, right? This is the same code. I've taken a node called p, and I'm saying p dot next is equal to top. What is our top? Our top is actually pointing to the initial thing. So I'm saying p dot top equal to p dot next equal to top, and top equal to p, right? So here what I want to say is, like, insert at beginning, insert at head. What we try to do, insert at beginning. If you go back to the code, we have taken the head, and we have initialized the p to the head, and we are saying p dot next and all different things, and finally we are returning. So we have done the same thing over here, guys. In the push, what we did is we have inserted at the beginning. So that is why I told you every topic is interrelated, right? So if we go back to our linked list insertion is beginning program, the same thing is happening. This is the same code, guys. I'm not going to explain all this to you because you already know all this, right? So one more thing is delete, right? I told you, where should we be deleting? We should be deleting at what? At beginning, right? We should be deleting at beginning to get this order of one time complexity. The same thing, this code is nothing but delete first. In the deletion of linked list also, we have seen three cases: delete first, delete at index, and delete at last. So here I'm saying delete first. So I'm using the same delete first logic over here. What I did, I've taken a p variable called p, initialized that, and then I've taken some data over here, and I'm saying p equal to p dot next, which means, for example, let's say here is my example. So let's say here is my head, right? I've taken a variable called p, and I'm initializing that to head. I'm taking a value called x is equal to p dot data, right? P dot data, I'm just having this x. I'm saying p is equal to p dot next. When p is equal to p dot next, p is not this one, but p exactly is this, right? P is happening here, which means if my p is this, which means my head is this, and I'm returning from here, right? Returning, which means I'm discarding this head, which means I'm deleting at first. And this node is gone. So what will I do with the x? In the pop method, if you see the return type is an integer value. So what is this integer? It is the integer value of the the value of the node that we have deleted. In this case, the x value will become 1, right? What I did, I've taken a value called a reference variable called x. I persisted this value, and what I did, I'm returning this value called x. That's it, right? Deletion at beginning, and I've taken this value called x, and I'm returning, right? In our case, if it is empty, we have written this empty condition. If not, we have written all this, and finally we try to implement that, and this simple our code would be, right? This simple our code would be, right, guys? Yes, I just paused the recording for the explanation, and yeah, I'm resuming my recording now. Fine. So at this particular point, guys, we will be going to our last topic for today, last thing for today. That is also going to be similarly simple, right? Similarly simple. So what is our last one? Our last one would be something like this, something like this. What it says, you need to implement a queue, you need to implement a queue using a linked list. Okay, fine. You need to implement a queue. I think the headings are wrong, guys. Maybe I'll correct them. I'll correct them and I'll give it to you. So what should you do using a linked list? You should be implementing a queue, right? So what is our conditions? Let's straight away jump into the conditions. The conditions are, initial condition would be front equal to null and rear equal to null, right? Similarly, what we had in our array, right? So what is our empty condition? Empty condition is when front is equal to null, which means it is an empty one, right? When front is equal to null, it's an empty one. The full condition would not be available. It's obvious from our previous explanation. And how do you find the elements count? You need to maintain a count. I think this is also a program that I covered in my initial linked list classes, and you can straight away use that method or implement your own method, and you can do that. So this is the element count that you can write. And with this all, let me straight away jump into the code and show that to you. So what is that? My queue using a linked list. So this is the my queue using linked list. So what it says, my initial condition node of type node, I've taken two reference variables, which is front and rear, and I'm implementing or initializing them to null, right? I have a push, I have a pop, right? I have is empty condition. So what is my is empty condition saying? Front equal to null, then return true or else return false, the same thing. And is full condition is not available for us, and we have to maintain count. That is a homework for you, right? Here the push and pop, these are the two methods, right? What is the push method saying? Push method is saying, I told you we need to insert at first, right? We need to insert at first. This simple logic is insert first logic, right? Insert first logic in the linked list, right? What is the pop logic saying? Pop logic is first initially checking if it is empty or not, right? If not, then I'm taking this value called x, and what am I doing? I'm trying to remove or delete at first. So this simple code is saying delete first in linked list, the same thing we have done in our starting classes, right? So using the previous knowledge that we have, delete first and insert first at linked list, we are able to achieve the functionality of push and pop, right? We have achieved the functionality of push and pop. So I told you we are using the same node, right? We are using the same node. What is this node? Data and next. This one we have done in our previous classes as well, right? So with this, guys, this is the simple code. This is a simple code to implement linked list. Implement a queue using a linked list, right? So as I told you, the conclusions are very important, right? Writing tables like this, or maybe writing, understanding before you write, or maybe trying to find the different cases, and then you start writing is very important in data structures. The reason is like, if you do not have conclusions upfront, then as you start writing code, you have to scratch your head and say what is happening, kind of. So that's why before you start writing the code itself, you need to understand, or you need to analyze different cases, what are the methods to implement, and then you have to start writing code so that it becomes very easy, and that code will be looking as simple as the one that I told you, like as simple as the one that I told you, right, guys? So I did not find any HackerRank links for this, because these are the basic ones, this basic implementations people like. I did not find the HackerRank links, and in case you find it's good, you can share with the people. But at the same time, what I want to say is like, with this is the knowledge for us. This is the knowledge for us to implement stack and queue using linked list and array, that too in order of one time complexity. You can go back, and actually see, are we doing it in correct way? Are we doing that in order of one time complexity or not? And you can conclude, right? So tomorrow what we'll be doing is we'll be solving few interesting interview questions on stacks and queues, right? So those also will be looking very hard, will be seeming very hard, but actually when you dig into, or when you write some tables like this, when these are called as these are not called decision tables, guys, but maybe I'll come to that decision tables later on, not now. But if you have some tables like this, and if you have conditions like this, then writing code will become very easy, right? Writing code will become very easy. I think we are done with the time for today, guys. Tomorrow we'll be seeing interesting interview questions. And with this point, let me end the class for today. Have a nice day. Bye.